In the last video, we talked about connective tissue, and it connects and binds. Now, there's two big groups. There is proper and supporting, or special, if you look on that website you all look up your papers on. Now, supporting is bone and cartilage. And when we had an 18-week semester, I would lecture on supporting connective tissues here, and then repeat everything in chapter 6. There's no reason to repeat myself, so we'll save off the supporting connective tissues to chapter 6. Now, proper connective tissues have 3 groupings. There's fluid, there is dense, and there is loose. So, according to your book, we have connective tissue proper. That's the dense and the loose one. I threw blood in there. I was taught blood is a proper connective tissue. We have supporting bone and cartilage. We covered that in a different chapter. And then blood is a fluid connective tissue. And I'll explain why blood is actually connective tissue. Now, Wikipedia, that website again, tries to throw lymph in as a connective tissue, and I will explain why I do not agree with Wikipedia. So, areolar connective tissue. You have fibroblasts that are loose and spread out. Now, you're going to have these collagen fibers. Remember, collagen fibers do not branch. And then you have the thinner elastic fibers that do, that do branch. So here are the branching elastic fibers. Now it also has reticular fibers. The fibroblasts are probably attached to the reticular fibers because fluid is moving through this tissue. So it is the most widely distributed connective tissue. Connective is the biggest group, and areolar is everywhere. Most widely distributed connective tissue. And it is soft and pliable, because it has all the space for fluid, which is ground substance. It has all 3 fibers loosely arranged. And it underlies most epithelial, is between muscles, gives passageways for nerves and blood vessels. And it holds excess fluid like a sponge. So remember I said you're sad, you're eating potato chips and drinking a lot of soda, studying for your tests on Saturday night. You're going to swell up with fluid, and that's because it can go in here where the ground substance is. Adipose connective tissue. Okay, fat. Now, you have the cell right there. Then you have an inclusion, and this is lipid. And usually the cells like to hang out together, like that, and then the lipid droplets form a flower off of it. I'm so tempted to put yellow there. So here's the nucleuses of the cells, and then here's the inclusions. Now this is different from simple squamosal, where you would have, if you actually looked at it closely, a lot of little cells with nucleuses. So I once on a lab exam put them next to each other, thinking it'd be nice to put them by each other so you could compare. Apparently I was the worst person in the world that day. They said it was so confusing having them next to each other. So adipose connective tissue is fat. You have empty looking cells. I've actually learned because the lipid is gone when it gets stained. So you have these empty looking cells with thin margins, nucleus pressed against the membrane. It contains large lipid droplets. This is the matrix. So this is actually the bad boy. It's not a carbohydrate or a protein or a salt. That's the matrix. It is fat. So we should throw this one out of connective tissue. It stores energy, insulates, cushions. We're not going to be able to play with the hearts, but students are shocked at how much fat is on the heart. And that is actually protection and energy for the little heart. Reticular connective tissue. Guess which fiber it has? That's right, it has reticular fibers. So we have these reticular fibers. And then you have the cells usually attached to the fibers. Now, they look a lot like elastic fibers. and it sucks in some tissue. They're next to each other. But generally, you have these branched reticular fibers, the cells attached to it. It's a loose network. It's where you have flow of fluid, so it's holding the cells in place. So it forms the framework of lymph nodes, tonsils, the liver, the spleen. Okay, mesenchymal connective tissue. Its other name is embryological connective tissue. I just like saying mesenchyme. It has lots of reticular fibers, lots of stem cells. This actually gives rise to all lymphatic tissue, all blood vessels, all connective tissues, muscles, and fibroblasts. So this is where most tissues come from, is mesenchyme. Now, adults have some mesenchyme. They're actually working on trying to stimulate it to grow organs and grow back muscles and stuff. And I have no idea how they're doing on that research. Okay, dense regular connective tissue. This is the one I showed before, where you have the collagen fibers going in regular waves like this. And sometimes it's stained blue like this, sometimes it's stained red and it looks like muscle. I hate that stain. So we have this regular pattern. Yes, this is very Zen-like. Then we have fibroblasts. Sometimes they're nice and stacked up. Sometimes you'll see one there and one there. It's not as regular. But the histology looks like this regular pattern. And the fibroblasts are going to be nice and sort of line up. Now, it's very strong in one direction. If force is applied in another direction, it will rip. Klay Thompson going up, I believe it was for a layup or a block. He landed wrong and he tore his ACL because his knee twisted the wrong direction. My friend Didi, All-American Division I soccer player, playing a pickup game after graduation with this guy who did not like her scoring goals on him. He cut her legs and her knee twisted 90 degrees, broke her ACL, her MCL, and I think another ligament in there too. So they're strong in one direction. If you apply force somewhere else, it breaks. Now, tendons attach muscle to bone. You need to know that. Ligaments attach bone to bone. Then fascia will wrap around groups of muscles. I'm not asking this on the first exam. I know I'll mention fascia in the future, and students will go, what is fascia? So it's just dense regular connective tissue around muscles. And it looks the same. Here is a tendon because it's connecting muscle to bone. So that's the extensor digitorum. It's my favorite muscle in the hand. It extends all of the digits. And then this is the infamous ACL right there. Now, I like this one more than dense regular. It looks like a Picasso. So these are the collagen fibers. And they go any which way. It's randomly packed, randomly arranged, but it's collagen fibers. It withstands stress in most directions. And this wraps most of your internal organs. It wraps the lower part of the skin, the deep dermis. And I always think it looks like a Picasso painting. Blood. It's a connective tissue. It is surrounded by a fluid matrix that has proteins and carbohydrates. So this is the matrix. So when I ask you what is the matrix, you will say the plasma, the fluid around the blood cells. Fibers are visible and clotting. It is a true connective tissue. It connects organs. It binds them together. It transports things. White blood cells protect us. It is the perfect example of a connective tissue. So, which tissue has protein fibers going the same direction and is found in ligaments and tendons? Not same. No, we didn't talk about. Must be dense regular. Only fluid connective tissue. Blood. Saliva is not a connective tissue. No cells. Not fluid. Oh, I was promised why lymph is not a connective tissue. Lymph has proteins. It has in it, so you could argue that's its protein fibers. but it doesn't really have cells. The cells are embedded in lymph nodes. So that's why I say lymph is not a connective tissue, as it doesn't have cells. It has the proteins, it has sugars, but no, it's not a connective tissue. This connective tissue is the most common one. It's found around muscles and nerves. It also is under most epithelial tissues. No. I seem to put that on everyone. It is areolar. Wraps most internal organs found in the deep dermis. Fibers go randomly. That's irregular. So dense irregular. So, oopsie, I already talked about lymphatic tissue. Contains white blood cells. That's separated by fluid. Has some carbohydrates and fluids. Cells don't touch. I usually make students raise their hand. Usually they say no because I think I sort of give it away that I don't think it is. That's a good critical thinking question. Should it be considered? I have seen the argument for yes, it should be considered. It is a valid argument. So we're going to look at muscle and nervous tissue. There'll be one question. And let's look at it. Both muscle and nervous tissue are excitable when you get stimulated. Both have receptors for neurotransmitters that excite it. When a neurotransmitter binds to a muscle, it contracts. When a neurotransmitter binds to a nerve, it either signals or stops a signal. Which one is contractile and excitable? It's muscle. As you can see, that was a very detailed lecture on those tissues. Which one is excitable and sends messages? That would be nervous. So again, that's all I want you to know for the last two. Each one of those gets its own chapter. So I'm going to ask you one question on this coming up test, and then more detailed when we get to chapter 12, and I believe chapter 10. So that is all. Oh, in our last video, we're going to look at aging and growth, and we're actually going to look at membranes around organs. It's a weird place to put it. It leads us into the next chapter, though, so thank you.